Hello, AP Stat students. So last time we learned how to compute one sample t interval for means. Today we'll be talking about some of the same stuff with a little twist. Using t procedures wisely. Procedures that are not strongly affected when a condition for using them is violated are called robust procedures. For confidence levels, robust means that the stated confidence level is still pretty accurate. If outliers are present in the sample, then the population may not be normal, and T procedures are not robust against outliers because when we learned in first semester, the mean and standard deviation are not resistant to outliers, whereas the median and IQR are. But we are interested in means in this unit. For using one sample T procedures, here's the caveat with the normal condition. You must graph to check. You enter data into your list. You go to stats, you go to edit, you enter your list into L1, L2, whatever you want to do. And then you go to stat plot. You can get there by going to second and then Y equal. And then this is the little screen that you'll see. You want to choose the sixth plot, the last plot on the far right, and that's from chapter 3, and that is our normal probability plot. You click on zoom 9 so you can see the whole graph. If your graph looks like a straight line, then your data will show the approximate, or you can conclude it's approximately normal, my bad. And then so here's the deal. If the sample size is less than 12, you may use T procedures if the data appear close to normal based on your normal probability plot. If it is skewed or has outliers, do not use T procedures. If the sample size is at least 15, but less than 30, the T procedures can be used, except if the data has outliers or strong skewness. Slight skewness is okay. Strong skewness is not. And lastly, if the sample size is large enough from the central limit theorem, so if the sample size is greater than or equal to 30, you don't have to show a graph to prove the normal condition. The T procedures can be used even for clearly skewed distributions when the sample is large enough. All right. So how does the four-step process change for finding the confidence interval for means? The only part that changes, so your state part is the same, your plan part is the same as far as the using a one sample T interval. The random condition is the same. This is different. So now, if the sample size is less than 15, as long as there's no outliers or skewness, it will meet the normal condition. If the sample size is greater than or equal to 15 but less than 30, and if there are no outliers or strong skewness, that will meet the normal condition. And when the sample size is greater than or equal to 30, it meets the normal condition no matter what. For these two right here, you must graph to get credit or you'll be in trouble. So sketch the graph out so people can see what you're doing. Graders, mean, so on. Right? And the independence condition is the same. The due portion, you need to compute your statistic, your sample standard deviation, your T star. I didn't even put that in here. And then you compute the interval, then your conclusion. Example problem. Can you spare a square? As part of their final project in AP Statistics, Christina and Rachel randomly selected 18 rolls of a generic brand of toilet paper to measure how well this brand could absorb water. To do this, they poured a quarter cup of water onto a hard surface and counted how many squares it took to completely absorb the water. Here are the results from their 18 rolls. So, 29 squares, 29, and so on. Construct and interpret a 99% confidence interval for the mean number of squares of toilet paper needed to absorb a quarter cup of water. So estimate the true mean amount of toilet paper needed to absorb a quarter cup of water with 99% confidence. Use a one sample t-interval for means. To estimate our mean number of squares of toilet paper. Check our conditions. Random, it is a random selection of 18 rolls. Normal, definitely not, because 18 is not greater than or equal to 30. Therefore, we must graph our data, and I will show you on a separate video of how I went about doing that. But I'll sketch the graph in. So here's what the graph looks like. Okay, this is my normal probability plot. Okay. So I'll try and do the best I can from what I remember, from what I see. Okay. So it looks pretty linear. I mean, you see this little portion right here, but overall it looks pretty linear. Don't let a few points let you conclude that it's not. There's a slight skewness, but not strong skewness, so it's okay. So it's robust. And robust just means close enough to meet the normal condition. Right, and for the independent condition, it is reasonable to assume there are more than 180 rolls of that brand of toilet paper. All right. Use a calculator to calculate the sample mean, the sample standard deviation, and T star. So going back to first semester, to calculate those basic statistics, we did the one variable statistics. So we went to stat, we went to calculate, and we did a one variable statistics. And we would get, or in this particular case, and I'll show you on my calculator, the sample mean is 24.94. The sample standard deviation is 2.86. And our T star, we calculate doing an inverse T, the area 1% split, so 0.5%, that is 0.005. Degrees of freedom, 18 minus 1. Okay, so your interval, your statistic, X bar, which is 24.94, plus or minus critical value, which I didn't even put here, it's 2.898, times the standard deviation of our sample, 2.86, divided by the square root of our sample size. That gives me 24.94 plus or minus 1.95. Lower bound is 24.94 minus 1.95. Upper bound, 26.89. We are 99% confident that the interval from 22.99 to 26.89 captures the true mean number of toilet paper squares needed to soak up a quarter cup of water. So the main thing about doing that example is to show you the graph and go back and enter a list and do a one variable stats. Right. We can also calculate an interval on the calculator using one sample t procedures. So there's two possible ways as far as what you're given. So for the example that I just did with the toilet paper, we were given individual data that we had to enter into a list. So we would use these 9 steps for individual data. And it's pretty easy. You enter your data into list 1, then you press stats, then you arrow across to test, and you are going to choose the test number 8 t interval. For the inputs, there's a choice. You can select either data or stats. You want to select data. You want to select where your list is, whether it's list 1, list 2, depending on where you selected it. Frequency, leave it alone because there's just one of each number. Confidence level, put the value if it's 0.95. If it's 95% confidence, put 0.95. If it's 90.90 and so on, hit enter, and it will give you the interval. So, and I'll show you how to do that. For this other side, these 9 steps, use it when you, So use this with your mean, standard deviation, and sample size. So you don't have to enter any data. So you go to stat, you scroll to test, you arrow down to the same t interval, but this time highlight stats and then enter your mean value, enter your standard deviation, enter your sample size, and enter your confidence level. Once you hit enter, you will be given the confidence interval. All right, so let's do an example here. It's our last one. The makers of Aspro brand aspirin want to be sure that their tablets contain the right amount of active ingredient. So they inspect a random sample of 36 tablets from a batch of production. When the production process is working properly, Aspro tablets have an average of 320 milligrams of active ingredient. Here are the amounts in milligram of active ingredient in the 36 tablets. So in the table below, you see the amount of the milligrams of active ingredient in the 36 tablets. What do these data tell us about the mean acetylsalicylic acid content of the tablets in this batch? Be sure to include the appropriate statistical evidence to support your answer. So we want to estimate the actual or true mean amount of active ingredient in Aspro tablets with 95% confidence. Doesn't tell us, so we're going to use 95%. Doesn't tell us which one we're supposed to use. Okay. Use a one sample t interval for means as long as conditions are met. Check conditions. Random. It's a random sample of 36 tablets. Normal. We have 36 tablets, and luckily that's greater than or equal to 30, and we don't have to graph this. That is fantastic news. And then lastly, independent. reasonable to assume there are more than 360 tablets of Aspro. My hand's starting to hurt here. I know another student whose hand hurts. He told me so himself. All right. So in this do portion, we can do everything on a calculator. However, to get credit on an AP exam or even my class, you need to show the numbers that you're plugging into your calculator, but you may skip a step. So you definitely have to enter all 36 values in a list so you can figure out what the sample mean and sample standard deviation are. And I'm going to go ahead and tell you what they are. So the sample mean is 321.03. The sample standard deviation is 3.03. And then we have to calculate T star. So T star is equal to inverse T. Okay, so area will be 0.025. And our degrees of freedom will be 35. And so that'll give us a T star, our critical value of 2.03. Okay. And I'm just writing down what we would have to do to get full credit. Using the calculator is just to check yourself. So we have our statistic 321.03 plus or minus T star times the standard deviation of our sample divided by the square root of our sample size, which is a nice number. So, but anyways, here's the part you can skip, all the intermediate work, and you can just write down the interval that the calculator will give you. Now, if you don't trust what you put in the calculator, that's on you, and you might want to actually show this to double check. But this part right there, you definitely need to show. And this part you're going to get by putting the list into your calculator. So you get the interval. So now for your conclusion. We are 95% confident that the interval from 320 to 322.05 captures the actual amount of active ingredient in Aspro tablets. All right, to conclude, let's look at this cartoon. Taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. This guy's never wrong. And the reason why the guy is never wrong is because the interval is so super duper wide, but it doesn't tell us anything. It doesn't help anyone with anything. There's really nothing useful about an interval being so wide and not giving us any information. And those are your notes for today. Have a great day, AP Stat students.